In section 1.5, we want to use quadratic equations to solve word problems. And so let's get right to it. The directions just say set up and solve a quadratic equation to answer each question. It might be possible to solve, to answer the question without a quadratic equation, but let's make a point to set up a quadratic equation in each case, in each problem, so that we get the practice. So in number 1, find two consecutive integers whose product is 110. And so there's some important vocabulary there. Integers is a set of numbers that we talked about earlier in the chapter. Do you remember what the set of integers is? It's 0, 1, 2, 3, and so on. And it's also the negative numbers, -1, -2, -3, and so on. And so we're looking for numbers from this list that we're looking for two numbers in this list whose product is 110. Of course, product just means multiply. And so we want to multiply the two numbers together to make 110. Now there's one more key piece of information in this problem, and it's the word consecutive. So consecutive just means that the one number is right after, the second number is right after the first number in the list. So we could have 2 and 3, or we could have 5 and 6, or we could have 117 and 118, right? As a pair, these are consecutive integers. As a pair, these are consecutive integers. So what's the relationship between the two integers? Well, the second integer is exactly one more than the first integer. So when we write x times x plus 1, that's the product of two consecutive integers. And then we just want to make sure that that product is 110. And so here is the quadratic equation that represents this situation. And we can go ahead and solve that equation. You might say, wait a second, that doesn't look quadratic because it doesn't have an x squared. But in fact it does. Remember, the first step is going to be to distribute the x to each term inside these parentheses. And so then we'll have x times x is x squared. X times 1 is just x, and then that's equal to 110. And now we recognize this as a quadratic equation. There are a few different ways we could solve this equation. We could try to factor it. That would probably be the best first step. And then if factoring doesn't work, we could use the quadratic formula. That will always work. And then if we just like completing the square, then we can complete the square. If that's fun, or if you want to practice, then you could practice solving this equation by completing the square. And of course, when you complete the square, then you're going to use the square root property. So that's all 4 methods that we talked about for solving a quadratic. Okay, so anyway, usually the best first step is to try to factor. And so if we're going to do that, then we're going to set the equation equal to 0. We'll get x squared plus x minus 110 from both sides to make 0 over on the right. And then we're asking at this point, okay, we need two numbers. In order to factor this, we need two numbers that multiply to -110 and that add up to the coefficient on x, which is just a +1. And so you might see that pretty quickly. That sounds like 11 and 10, or to be more precise, that would be, let's see here, that would be +11 and -10. And so we can take those two numbers and write the factors x plus 11 and x minus 10. Their product is equal to 0. And so if we have x plus 11 equals 0, then x is equal to negative 11. And if we have x minus 10 is equal to 0, then we have x is equal to 10. Okay, now remember, negative 11 and positive 10 are not the consecutive integers. What this tells us is that we have two possible outcomes, two possible solutions. And so if x is 10, then the other integer that goes with it is x plus 1, 10 plus 1, which is 11. So we've got 10 and 11 as a solution. And we could also have x equals negative 11, and then x plus 1 is negative 11 plus 1 is negative 10. And so the other possibility would be negative 10 and negative 11. So two different possibilities. You can check that these are both correct because you can go back to the problem. Are they consecutive? And is their product 110? And for each pair, you would say yes. Okay, let's go on and do one more problem here. In each of these problems, and in general, when you're watching the videos, if you think you could start the problem on your own or do the problem on your own, that's usually a good idea. Pause the video and then come back to it after you've had time to think about it on your own. The problem says that the length of each side of a square is 5 inches more than the length of each side of a smaller square. And the difference of the areas of the squares is 95 square inches. Find the lengths of the sides of the two squares. So two squares. There's a smaller square. There's a smaller square, and there's a larger square. And what do we know about the length of each side of the squares? Well, for the larger square, the length is 5 more than the length of the smaller square. So on the smaller square, we'll choose x. And it might be helpful if we just remind ourselves that all the sides of a square have the same length. And so we could write x on the vertical side of the smaller square, and on the larger square we could write x plus 5. Okay, so we have a little picture to help us get started. And so now we need to come to the next sentence in the problem, which says the difference of the areas of the squares is 95 square inches. And so difference means subtract, right? Means the larger area minus the smaller area equals 95. So let's write that out in words, and then we'll write it algebraically. The larger area minus the smaller area is equal to 95. So the larger area, for the larger square, the area is length times width, x plus 5 times x plus 5, or just x plus 5 squared. And for the smaller square, length times width is x times x, or x squared. And so here is our quadratic equation that we have set up, and now we just need to solve it. Again, if you think you could solve this equation on your own, then go ahead and do that. Okay, be careful when you multiply out x plus 5 times x plus 5. Don't forget the two middle terms. You wind up with x squared plus 10x plus 25 minus x squared is equal to 95. And then on the left-hand side, you see that the x squared minus x squared cancels, and you're just left with 10x plus 25 is equal to 95. And sure enough, we had a quadratic equation, but the quadratic terms fell out, and so now we have a little linear equation like we learned to solve earlier in the chapter. So we can just subtract 25 from both sides, and we'll have 10x is equal to 70. And then when we divide by 10 on both sides, we get x is equal to 7. Remember what x represents? It's the length of the side of the smaller square, and the units are real important in these problems. We want to write 7 inches for the length of the side of the smaller square. And then for the larger square, we'd have x plus 5, which is 7 plus 5, or 12 inches, for the length of the side of the larger square. And we're done.